Hello again, grade 12s. The question we are going to look at today is a combination of your grade 11 Euclidean work as well as your grade 12 Euclidean work. So the first part of the question, 10.1.1, that's definitely the grade 11 work, and 10.1.2 is Theorem 3 of your grade 12 Euclidean. So the question reads as follows. In the diagram, ABCD is a cyclic quadrilateral such that AC is perpendicular to CB and DC equals CB. AD is produced to M such that AM is perpendicular to MC. Let B equal to X. We need to prove that MC is a tangent to the circle at C. For us to do that, we first need to work out certain angles inside the cyclic quad and the triangles that you see. So for the first one that we're going to tackle is A2. So let's look at A2's positioning, right? This is within the first triangle that I'm going to highlight, and that's a right angle triangle. We know how to work out what A2 is. We will use our sum of angles in a triangle to work out what A2 is. So A2 is equal to 90 degrees minus X. That is your statement. Now the reason for that would be sum of angles in triangle. That is the reason that goes with the statement. Right, so we've just worked out that 90 degrees minus X is the size of A2. We can then work out other angles inside. The easiest one, looking at the cyclic quad to work out, would be your D1 there, okay? Alternatively, you could work out the exterior angle here, which is your D2. So the two processes there of working out what D1 is, then you could work out what D2 is. But we can work out D2 straight away, okay, because we know that that is the exterior angle of your cyclic quad. So D2 is going to be equal to angle B, which is equal to X. And the reason that goes with that statement is exterior angle of cyclic quad. Right, now that we've worked out those ones, we can work out what C2 and A1 are. Okay, so let us start with A1. A1 is going to be equal to A2, and why is that? That is because equal chords subtend equal angles. The last angle that we're going to work out is C2. Okay, so C2, let's look at where it's positioned. It is in the smaller triangle, okay, that I'm going to highlight now for you. There. We know how to work out what C2 is. We're going to use our sum of angles in a triangle, and therefore C2 is going to be 90 degrees minus X. The reason is sum of angles in triangle. Right. What we see here now is that A1, okay, this 90 degrees minus X is equal to your C2, which is also 90 degrees minus X. Based on that, we can now conclude, since A1 equals C2, both of them being equal to 90 degrees minus X, we can now conclude that MC is a tangent. Now, you need a reason for this, and this will be the converse tan chord theorem. Let us now look at the second part of the question. We are required to prove that triangle ACB is similar to triangle CMD. For any proof that is required that for similarity, what you need to start off by doing is stating the two triangles that you're going to work out in. So you're going to say in triangle ACB and triangle CMD. We will now set up our proof. We will first say that A2 is equal to C2. Remember, these were both equal to 90 degrees minus x. What was the reason for this? This was because of sum of angles in triangle. But since you proved it above, you don't have to write that reason. What you could write there is alternatively proven above. That's only if you've obviously proved it above, right? The second one, we then say angle M is equal to angle C. They're both equal to 90 degrees. We didn't have to work this out. This was given. For the last angle, you would then say that D2 is equal to B. These are both equal to x, and the reason there was exterior angle of cyclic quad, or if you have already proved it above, you could write or proven above. This is obviously dependent on whether you've actually proved it above. You can now conclude that, therefore, triangle ACB is similar to triangle CMD. You need a reason for this. You either write angle, 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 or similar triangles, or equiangular triangles.